I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to see the topic Antenna Fundamentals for the course Transmission Lines and Antennas. So if we see the antenna background, we know Maxwell, created the fundamental equations, and there are four Maxwell's equations, and Maxwell proved the existence of electromagnetic waves. And after Maxwell, Hertz, he introduced first aerial propagation, and in order to honor his name, the antenna is called as Hertz antenna. And after that, Marconi, he developed transatlantic transmission, and we can define an antenna as it is a way of converting the guided waves present in a waveguide, feeder cable or a transmission line into radiating waves traveling in free space or vice versa. It is a passive structure that serves as a transition between a transmission line and air used to transmit and or receive electromagnetic waves. And an antenna converts electrons to photons of EM energy and vice versa. It is a transducer which interfaces a circuit and free space. So in the picture we can see an antenna at both transmitting side and also a receiving side. At the transmitting side, we have a generator or transmitter. With that, a transmission line is connected. At the end of the transmission line, we have an antenna. Here, from the generator, there will be an electromagnetic wave which is guided through transmission line. It is a TEM wave, transverse electromagnetic wave, and it is a one-dimensional wave. And this one-dimensional wave is converted by the antenna as a three-dimensional wave, and it is radiated into free space. Here, the antenna is a transition device which converts one-dimensional wave from the transmission line into a three-dimensional wave into free space. This is the case of transmitting side, and at the receiving side it is vice versa, that is the three-dimensional free space wave is absorbed by the antenna and it is converted into one-dimensional guided wave and it is given to the receiver. So here only accelerated or deaccelerated charges radiate electromagnetic waves. A current with a time harmonic variation, that is the AC current, satisfies this requirement. And the role of antennas, there are many functions performed by the antenna. It can be used as a spatial filter, polarization filter, impedance transformer, and a propagation mode adapter. And if we come for antenna types, there are several types of antenna based on the variety of components. For example, according to frequency, it can be divided into many types like low frequency, high frequency, super high frequency, ultra high frequency, medium high frequency antennas, and also according to the structure also it is classified. So some of the classification of antennas here are end-fire antennas, loop antennas, dipole antennas, stubs, slots, aperture antennas are given in the diagram. And a very important concept in antenna is an isotropic antenna. It is a hypothetical antenna. It does not exist in real life. It is used for measuring bar for real antenna characteristics. And it is a point source that occupies negligible space and has no directional preference. Its pattern is simply a sphere, so it has a beam area is equal to W isotropic is equal to 4 pi steradians. So the isotropic antenna, it is double integral of 4 pi 1 d ohms. And here isotropic radiator is defined as a hypothetical lossless antenna having equal radiation in all directions, and it is a omnidirectional radiator having an essentially non-directional pattern in a given plane and a directional pattern in any orthogonal plane. This is called as omnidirectional radiator. Next type is the directional radiator. Here it is defined as an antenna having the property of radiating or receiving more effectively in some directions than in others. Usually, the maximum directivity is significantly greater than that of a half-wave dipole. So, this is an example for the radiation pattern of isotropic antenna, and the antenna radiation pattern is given in spherical coordinates since we are assuming the radiation occupies a spherical surface. Here there are two angles, one is theta, the elevation angle, phi is the azimuth angle. And another important parameter in antenna is the solid angle, and its unit of measurement is steradian. And here we can define the angle steradian as 1 steradian is the solid angle with its vertex at the center of a sphere of radius r, which is subtended by a spherical surface of area r squared. In a closed sphere there are totally 4 pi steradians, and this angle is given as S ohms divided by r squared steradians. And next important parameter for measuring the antenna parameter is radiation intensity, and it is in a given direction is defined as the power per unit solid angle radiated in this direction by the antenna. And radiation pattern is a three-dimensional graphical representation of far field radiation properties of an antenna as a function of space coordinates. So this radiation pattern, there are two types. One is field pattern, where the radiated radiation is measured in the field in terms of electric field. And the next type is the power pattern, where the radiation is measured in terms of power. And there are two planes specifically for measuring the radiation pattern. One is E plane and another one is H plane. If we see the radiation pattern characteristics, it is given in the picture. We have a major or maximum radiation lobe, and there are side lobes or minor lobes, and we have a parameter called 3 dB beam width, and it is also known as half power beam width. And we have another parameter called null, where the radiation is minimum. And another important parameter is front to back ratio. It is the ratio of radiation at the front side of the antenna to the back side. And gain, maximum signal position. And the picture represents the antenna pattern parameters. We have the major lobe, and the main lobe is the maximum radiation lobe. Half power points are the points where the power is half, and in between the half power points, half power beam width is measured, and in between the two first nulls, first null beam width is measured, and back lobes are given in the picture. So now the assessment, the units of radiation intensity is watts per unit solid angle, and the radiation lobe containing the direction of maximum radiation is called, we know it is major lobe.